In this video, we are going to discuss an overview of the topic of statistics. In order for there to be statistics, there must be a topic. For example, Math 1-to-1B students, followed by a research question or a research problem. It's basically, what about the topic that you are interested in? What variable concerning the topic that is of concern? So for this example, it's about the score. And what about the score? Is the mean. So the question is, what is the mean score of Math 1-to-1B students? Now, the mean here now mentioned is the population mean, which is symbolized as mu. Now, every question requires an answer. So an answer at the moment of the bat without evidence is called a hypothesis. Now, there are two types of hypothesis, the null and the alternative. The null hypothesis always carries the equal sign. So the null would say, well, the mean is 75%. Now the alternative now will refute this. It's like two persons debating. One said that the mean is 75%. The alternative says the mean is not 75%. And here, these two statements are translated in symbolic form. The population mean is equal to 75, that's the null hypothesis. And the alternative hypothesis is saying that the mean is not equal to 75%. So the objective is to determine the mean score. Now to do that, now you've got to collect data. As soon as you collect data, looking at the data that you have collected, most likely it will be impossible to determine that mean just by looking at the data. More so, you may not be able to determine which of these hypotheses is true. Or if to be more specific, if it's to reject the null or not. Just by looking at the data, can you determine that it is equal to 75%? Most likely no. So then you're going to organize the data. That means you are going to present it, make it presentable using tables. Again, looking at all these numbers in the table, can you determine the mean score just by looking at all these numbers in the table? Can you determine whether or not it is 75% or not? Or to be specific, if it's to reject the null statement or not to reject the null statement? Most likely no. So then you move on further. To represent the data, present it again using diagrams. You can use a box and whiskers diagram. Now, to construct a box and whiskers diagram, you must do some calculations. The quartiles, you must calculate the quartiles, the three of them, Q1, Q2, Q3. That's a bit of analysis that you are doing. So just by looking at the quartiles, the mere fact that you have calculated the median, which is related to the mean, both being central tendencies, you may or you may not determine if it is equal to 75% or not. So it is not so much of a convincing analysis. So then you got to move further now into the analysis now, which is calculation of descriptive measures. Here, is a list of the descriptive measures that we have calculated in this course, in this statistics course, Fundamentals of Statistics. The sample mean, the median, and as you can see, they are listed by the symbols and the words. The mode doesn't have a symbol because it's not so popular in numerical analysis. So a symbol was not required. Similarly, range. The interquartile range is normally abbreviated. Then you've got the sample variance, which is very popular, so a symbol has been created. Just like the sample mean, sample standard deviation, Spearman's correlation, Pearson's correlation, Spearman's ranking and Pearson's product moment, gradient, and y-intercept. Now, which one of these statistics, which one of these descriptive measures can you use to answer that research question? Obviously, is the sample mean, because that's what you set out to determine, the mean. So it will not be really necessary to calculate the rest of these statistics. They will just be add-on. You definitely need the sample mean. And after calculating the sample mean, for example, let's say you get a sample mean equal to 82%. So now you're going to compare what the data is saying with what the null hypothesis is saying. The null hypothesis is saying that the population mean is 75. The sample mean is, the data is saying that the sample mean is 82. Clearly, they are both saying different numbers. So the decision is to reject the null hypothesis. And the conclusion will be the alternative. It's like the alternative has won the debate. So based on the data, the mean is not 75% because there appears to be a significant difference between the two. So this is, in a nutshell, the process of statistics. Simple example.